There's lots of HTML, HTTP stuff, there's image stuff. A lot of these things are being moved out to sub-rep repositories, but the Go command line tool will, if you say Go install and then path to GitHub or other places where people keep code, will just pull it in with no. So as long as you have a network connection, you shouldn't notice the difference between having it installed yes or no. And the Go tool can even analyze your imports. Let's say, apparently I have to go get something from here or there, and I get it. So it's like the comprehensive Perl archive network. It's filling up with useful stuff faster than we can describe it. The Go 1.0 will define the APIs of the basic stuff. That means that some of the crypto stuff is going to move out, but that won't actually affect how hard it is to use it. I don't know, what's missing? What's missing? Missing is a good program to find out if a web page contains true things, or maybe also, we're working on that. Truthiness.
Are there threads in standard library or
no. The threads are done by the Go runtime. So there are Go routines.
Wait, but what if you have to use threads like for some dependency in C?
So if you linking stuff to C is a separate exercise. So you can call C code and it has its own threads, and you can start threads from there. But there's no way to access threads. You can fire up Go routines. And you can set an environment variable saying distribute this over this many system threads, and you can increment or decrement that even from the inside of it.
Yeah.
But then you should not mess with threads yourself. It's like in Java getting raw pointers into the binary image of the JVM. It's just not how it works. So I can't say I've run into a case where it's necessary. Ever. So if you call into a C or C++ library that fires the threads, that will work because it is linked against the threads. But
one thing that is missing is in the toolkit, like binding like GTK or something like that. This is working on currently being working on by the
oh, there was this guy.
Yeah.
Oh. There's some stuff like that. There was also some Windows stuff.
Yeah, and like I've seen like last month there was some guy who was playing with the GeoJet binding.
Yeah.
I don't think there is Shruti binding yet.
Yeah, most of the adopters work on either system stuff or web stuff, but I'm sure we'll see the new things.
Yeah.
You first.
Oh, sorry. Well, I was just related to this saying, maybe I think, is there any kind of 1 year, 2 year roadmap where you're going with this? Is there any kind of indication of how committed Google is to this? Or?
Oh, very, because it's one of the 4 official languages you're allowed to write internal stuff in. And so what we see is, originally, the creators expected a lot of adoption from people who were not so happy with C++ anymore. But what we see in practice is that the people that we call them SREs, there's one in our midst, the people that run our systems, the people that keep an eye on things not exploding in actual real time, they write a lot of tools to monitor clusters and stuff, and the tool of choice used to be more or less Python, to just cobble something together to quickly scrape something in. And now, what we like to emphasize also, is that these people think, wow, all right, it's a Go, and then they have a great time. It's just as fast to write it, it's 50 times as fast to run it, and it's actually maintainable, and you can check it in and keep it around for using later. So that's going well. Then there are some big systems, so you don't often get an opportunity to rewrite a big system from scratch. So there's a handful that have been done or are been doing. I'm looking for a new one like that myself. But that means Google is pretty damn committed.
and the roadmap? I mean, is the language still changing all the time?
No, so this is what, very good. So this is what the 1.0 is about. It's a stable version that everybody can rely on. And after that, we'll think about all the other things that people would like to see in there. So there are no, so one complaint comes up is there are no generics. Turns out, if you learn Go idioms, you don't really miss them that much, although sometimes you could argue that it would be nicer if they learned. So I'm sure this discussion will come up after the 1.0 launch, but stuff like that is all postponed until after 1.0.
This whole trade-off between keeping things backward compatible or saying, no, this is really better to do it this way, we'll move forward and
so the 1.0 will have incremental releases that are forward and backward compatible. And where that's not possible, we have a tool called Go Fix that occasionally, if an API changes, it will rewrite your old code into your new code for you. A Go-to may differ in arbitrary ways, but I don't think so. Everything that's on the list of nice to think about sometime can come up then. I have no idea how things will change.
Yeah.
So I don't expect giant fundamental overhauls. Actually, I have no idea what mine going to go to. Okay, is there some pizza left? Yes.
This one, this.
The whole one. Okay, thank you. The time I took, I might have stuck to Rob's talk in some more detail, but I hope it was useful anyway. And now,
I only have this like fishes.
I just want to think that.
Just have this up.
So yeah, Lucas told you about Go, the language, and I will tell you about how to do web application with Go on App Engine. So my name is Johan Euphrosine. I joined at Google Summit just 1 year ago. I'm a developer program engineer. I'm focusing currently on supporting the App Engine developer community, and you can reach me through my Google profile. So App Engine, the goal of App Engine is to allow you to run your program on Google infrastructure. So all the services that we use internally to run all our web properties, we are trying to make them available to you as APIs so you can run web apps that are using the same APIs that we are using internally. So the Go runtime is a bit different from the other runtime that we have in App Engine. Currently we have Python and Java, and the Go runtime is the only runtime that supports native code. So it means that when you are deploying a Go application to App Engine, this is like native code running. There is no JVM, there is no interpreter, it's straight native code. It's also the runtime that has the lowest footprint in terms of memory and also executable size. And also that's the only runtime that came out with concurrency built in. So with Java and Python, we introduced concurrency later. Like with Python, we introduced concurrency with Python 2.7. With Java, we introduced concurrency lately. But like with Go, because of the inherent concurrent nature of the language, with also concurrency built in, like Luuk has shown you with Go routine and channel, it was already working concurrently. So each time, the way it works on App Engine is that each time you get an HTTP request, it will create a Go routine in order to handle it. It doesn't mean that currently the runtime is single-threaded, so you still have only one Go routine running at a time. But if your Go routine is doing I/O, so if you go, and that's what most of the time you do on App Engine, because you are calling an API and you are waiting for it to return. If one Go routine is making an API call, then another Go routine will process an incoming HTTP request. And it appears to be like a really good fit for the App Engine model. So I will show you how to make a simple App Engine application on Go. So first you declare the package. Then we make some imports, so we'll need net-http to declare some handler, and we'll also need the font module in order to print things. So first you declare the init function, which will attach the handler of your application. So you just bind the hello function on the dash and the /hello path, and then the hello function has to implement the server HTTP interface. So it's taken a response writer as first argument and the request. And then since the response writer is just implements the writer interface, so you can use fprintf and just write hello buffer. So using the fun package, we are now writing hello buffer straight to the response. So for deploying an App Engine, you need a bit of metadata around your application. So you have to name your application, you have to say which version it is, you have to say which runtime it is, so the tool can figure out how to apply it. You have to target one API version in particular, so you can, for example, in the case of Go, they recently released an experimental runtime, which is implementing most of the Go one that will go out later, that will go out in a few months, or maybe sooner than that. You can explicitly target one API version of the runtime, and that's what I'm doing it because I want to use the last stuff, so I'm targeting Go 1 beta. And you declare your handler. So you declare the main. So if you look at the handler, they will get matched into sequence. So first, I'm going to try to match some. Yeah, so that shouldn't be here, but you can declare some static directory. So if I want some image in my application, I can declare the path and where to search the image. And then you can also bind all the subjacent path to your application. So you just say wildcard target my Go application, and all your requests will show up there, and we'll try to match what you are performing here. So in order to test your application locally, you just run the app server. In order to deploy your application, you run app cfg update and you deploy your application. So if you have a laptop, I encourage you to go to the URL there so you can try all the examples at the same time. So we can now try your App Engine application. Okay. So what happened here is that the application serving, so I'm actually serving my slides from App Engine. And all the code that you are seeing in the slide is also the code that is running the application. So we'll be able to test all the examples that we will see directly into the slide. So now we'll try to make some much more interesting stuff. So what I want to do is, I don't know if you are a fan of news websites like Hacker News or Programming Reddit. How many of you know about Hacker News? So I keep during the day, I keep checking Hacker News and Programming Reddit to see if there is anything about App Engine or Go. And yeah. And the thing is that I'm always checking them at the same time. So I open Hacker News, open Programming Reddit. And there is a lot of duplicate between the two. So we'll try to make an application that allows you that makes a foundation to allow us to check Hacker News and Programming Reddit at the same time and gain a lot of productivity. So we just make a new application. So it's the same package Gopher. It's declaring a new handler. So this is hackernews.go. So it's a new file. But you notice that it has exactly the same structure as before. So within my application, I can declare multiple Go files, that will attach some handler in the init function, and they are all going to get matched in sequence. So I'm going to import some App Engine stuff. So I want to be able to fetch URL, so I want to be able to fetch the Hacker field and the programming ready field. I need some XML library because I want to parse the RSS that I can use this serving. Like before, I also want to be able to print things nicely. I want to, that's an HTTP application, so I need net HTTP, and I import time because I want to sometimes show you how long it takes to resolve my code. So this is how the RSS feed of Hacker News look like. So you have top element, which is RSS, then you have some channel, then in the channel you have some item, and each item is either a title or a link. And the nice thing about Go is that it can parse all of this for you automatically, so in a keep-safe fashion. So you just have to declare some type. And you just have to make sure that there is either annotation to describe which field corresponds to which tag in the XML, and it will all gonna parse the XML and fill your structure and allocate your structure on the fly for you. So here I just define a type for my field, so it's a struct. There is field tag in it, and the field data as the attribute are on the tag XML. Then on each field data, I have a collection of items, and the name of the field is item. And then on each item, I have a title and a URL. So the title is title and the URL is link. The way it works is that if you, by default, if you name the field the same name as the properties, it will resolve it for you. But here I'm doing things explicitly for you to see the annotation syntax. And now I can parse it. So I will just create a new HTTP client, call URL fetch call the get method on the feed URL to get the response. If there is an error, I handle it. So here you see that Go has multiple return values. So if I call client.get, I get the response and the error, and then I can easily check and print a message if there is a problem. I will make sure to close the response body at the end of the function, so that's what the defer keyword is for. So the defer keyword goes like this. It will execute the statement that you put on the right at the end of the function on any of the return paths. So if I back up early because I have an error, it will execute it. If I execute my function till the end, it will also execute what I've said at the right of defer. And then I create the decoder XML. So I just initialize the decoder, pass the body, and ask him to decode one type that I've specified before. So I ask him to take the response body and decode the Hacker News feed. So it will search for the channel, search for allocate one item, fill the collection of items that I've specified here, and then for each item, parse title and URL automatically. I back up early if I have an error, and then I just return the item that I passed. So I return feed.data.item. So here you can see that we have data binding from our XML to native Go structure, just with some type definitions and annotation on only a function call to decode the field. And then I will print it. So remember, I've defined my Hacker News handle. It's taking a writer on a request. It will just declare the content type using the header function, and then call Hacker News item, get all the items, make a for on it, and just print them to the response. So here I can try. Here we have all the Hacker News basically just plain text. So we can do the same for programming. We try to do the same for programming rate. So here it's a bit different because the feed, the RSS feed of programming Reddit is a bit fuzzy. Like you don't have, actually the link in the access field is a link to the Reddit thread. It's not the link to the actual content. So it's not convenient because you have to parse the link inside the description, and it's HTML escaped, and that's a total nightmare. So what I'm doing there is I will use the JSON API of programming Reddit. So it will also show you how to parse JSON into code with code. So here, instead of importing encoded XML, I import encoded JSON, just declare the project number like before. And here, that shows you how the JSON data is structured. So you have it's very messy, very nested. So you have data, then you have a list of children. Inside each children, you have another attribute data, and inside this data, you finally have the TDAT of the URL. And so we'll do just like before, declare some tip to map the hierarchy of our JSON field. So we declare a Reddit field that is a Reddit data, and here you see that we don't have any annotation. Like because we've named our field data, it will automatically try to extract from the JSON the data attribute. And then my Reddit field data is a collection of Reddit feed item. Here I have to explicitly say that the attribute is JSON children in the same way I was doing before for XML. I'm just like saying JSON instead of XML. And it will automatically allocate and parse them into item. Then I have Reddit feed item, which only has the argument. And finally, I have my item argument, which turns out to be the same that I'm using for the XML. So here we have two different structure, one JSON, one RSS field, and they all get parsed at the end into the same data type, which is an item with a title and a URL. And here is how I decode my JSON field. So it's not different from before. The code looks very similar. The only thing changing is instead of calling XML new decoder, I call JSON new decoder. And also because there is this extra level of nesting, I have to make a last for loop here, so I could return a collection of items and not a collection of Reddit data item. I don't want a collection of items with data attribute. I want a collection of items with URL and title. And then I print it just like before. And here, yeah. And now we'll make Proginator, which is news combinator with programming Reddit all into one website. And so I will just call the function that I've done before, like get the item of attributes, get the item of programming Reddit, and make a for loop to print the item for attributes, and make a for loop to print the item from programming Reddit. So here, all the news, so much rate. So here you have some timings. So Hacker-News take 200 milliseconds to fetch. Progate is a bit faster, like 100 milliseconds. And you see that Proginator function takes the addition of the two, so 300 milliseconds to fetch the two together. But we can do better. We can make it concurrent. So because we don't want to depend of. We want at most to wait for the slowest website and not the addition of the two websites. So what we do, just like we have shown before, we just add some go call here. So instead of calling Hacker-News item, I declare a new closure. So just like I would do in JavaScript, I declare my function on the fly, and I call the go keyword on them, which causes them to be spawned into go routine. Instead of getting the result and returning it, what I'm doing is that I'm embedding it in a channel. So I created a channel of item slides. So I have a channel, and I put some collection of items in it. So here I fire my go routine, and then when I return, I emit it in the channel. Concurrently, fire another go routine, which we call progate, and emit in the same channel. And I don't know which will resolve first, but I don't care because in the end, I just want to put all of them. And then I know that I have 2 results to get from a channel, so I just do a for loop. And as soon as I get 1 result from the channel, so here is the status, I receive 1 argument from the channel, I received a channel, I received an item collection, I just for it and print it. So here I don't know which I will print first. It will be hacker news or progit, depending on which one is fastest. So here, same, much faster. And here we can see that instead of taking 300 milliseconds, we just take like 200 milliseconds because we depend on the slowest one, and we don't depend anymore on the addition of the 2 latency. So that's all that I had. So way more faster than Luuk. So I'm glad that you will take more time because it will be really fast. So a few takeaways from this talk. Quick introduction. So the encoding package makes parsing fun again. So you don't have like usually parsing XML and JSON is boring, but here it's fun because you take your time and parse everything automatically. And the go runtime is inherently concurrent, so we have seen that one coroutine is spawned each time we have an HTTP request. So for our Reddit example, for example, if I had one coroutine which is like waiting for Reddit to respond, and one other coroutine waiting for news Y Combinator to respond, and at the same time I have another guy who wants to do hello buffer, like the first example, it can be served within one App Engine instance just by spawning a new coroutine, because my 2 coroutines that were originating from my previous request will all be waiting for I/O, and the other one, the runtime will spawn another one to handle any new incoming request. And so that means that actually the App Engine runtime, the Go App Engine runtime is much running your application on the Go App Engine runtime is much cheaper than it is on other runtime, because the way App Engine works is that as you get more requests, it will spawn more instances to serve your application. So you have concurrency in a way because you have multiple processes serving your application. But with Go, you will, with a smaller amount of instances, because concurrency is built in, and one instance can process multiple concurrent requests, you will have a way much smaller instance usage that you have with the other runtime. And also it's faster because it's native. And also one key difference between the other runtime and Go runtime is that on Java and Python, if we need to do things asynchronously, like I've shown you in the last example, we have to do a new API. So in Python, you have the synchronous API for URL fetch, and then you have the asynchronous API for URL fetch that take a callback. And here in Go, we only need one API. We can use the language primitive to do things asynchronously. And there is some homework for you. So you can try to remove duplicates and sort instead of printing then Reddit, and first Reddit and then Hacker News, you can try to sort them by ranking and print all of them, like interleave them to print the most relevant link from either of the website on the top. And you can make it ready with the template package and add some CSS. You can try to fetch feed offline with TaskQ. So TaskQ on App Engine is a special type of request, so you can ask your application to issue a request to yourself to do some work. It's happening offline, so it's not a request coming from live traffic, it's to scale some job in background. So what you could do is, for example, like every 5 minutes, fetch Reddit and Hacker News, store it into the data store, and cache it into main cache, so it's rendered instantly when someone is visiting the web page, instead of fetching Reddit and Hacker News for each visitor. And you can go for the messy code, so just on cut.google/p-pollinator. So thank you. So some resources, the App Engine SDK for rules, the doc are here, the reference of the language, golang.org. If you add weekly dot in front, you have the less fast Bing's documentation, and you will see that it looks a lot different. And here you have my Google Plus profile where I post stuff about that engine. Thank you. So yeah, do you have any questions?
When the app engine for Go was out, there was they said that there was a limitation that only one native thread
Yeah.
was
Yeah.
run. Is that still the case?
Yeah, it's